thank you all for lasting this long through what has been, I'm sure, a very interesting day and lots of very hard acts to follow. So I'll see how I go. First slide, what have we got? A bunch of rocks. What city is that, Sarah? Whoever can tell me what that city is, there's no lollies here, so no prizes, sorry. Okay. Chicago? Well, here's a more pertinent question. Are you a data scientist? And we have a picture that's commonly associated in the minds of non-data scientists with actual data scientists. They probably think we look like this. Well, here are some questions. Are you managing a data scientist? Are you looking to hire a data scientist? Well, there might be some additional questions if you're one of those people. You might want to know what software you should buy. In fact, I'm sure a number of the presentations here have covered amazing feats of technology and confused people getting into the field even further with what tools they might want to acquire. Equally, who should they hire? There aren't enough data scientists to go around, apparently. But at the same time, there seem to be conferences full of them, here, for example. So who should I hire? Which ones are right? And more to the point, a very pertinent question affecting a number of the corporates, also a topic I have a lot to say on, and you can, if you really want, go to the media section of my website, which you can see there, and you can see a talk I do called Questions You Should Ask Your Prospective Employer, where I give my thoughts on why, in fact, this churn is happening. But how do I retain data scientists is a big question for a lot of corporates. And of course, number one question I seem to be asked by beginners is, I've got all of this data, how do I turn it into gold? Because apparently data turns into gold now, doesn't it? Nope, this is not what I'm going to be talking about today. I am, however, going to be talking about something kind of related to the last question. But in a much more focused way. I'm going to talk about how to manage and leverage the value of data science in business. So hopefully that will constrain things nicely. So what are some of the things I'll talk about? Oh, why is my arrow there? Go away, arrow. So first of all, a whole bunch of shameless promotion about me, because I like talking about me, and hopefully you do as well. The perhaps most salient part of this talk will be a discussion of the difference, and indeed the opposites that are data scientists and data engineers, and the fact that most businesses don't know which one they need, or which one to put in what role, or how to manage them, or what they're for. Following on from that, we'll talk about where data science fits in a business, and more broadly about the state, the nature, and indeed the health of data science and analytics today. Related to that last point is a very pertinent question that I always ask in my mind, and increasingly I ask verbally when I talk to prospects, which is, do you really need data science? Yes, I know you're waving a whole lot of money at me right now, but do you really need data science? Or do you need something else? Or perhaps, you don't actually need anything at all. You just like to spend some money on something that sounds cool. And finally, time permitting, I may talk about some answers to that question of how do you find, train, and manage data scientists. So perhaps, while I won't be focusing on those questions at the beginning, I may get round to at least some of them at the end. Here comes the shameless self-promotion. So you can ask me about a whole lot of stuff. You can ask me about Prescient, which is my training company. For some reason, everyone says, oh yeah, you do those R courses. Yeah, I do R courses, about 2 of the 12-odd courses that we run, which are mostly on things like machine learning and data science and forecasting and things that may use R, but R is certainly not the most central thing. By the way, this incessant centrality of tools, which are actually irrelevant and interchangeable, is something that I keep seeing in the industry, and perhaps you do as well. the tools are very tangible and give people something to hold on to, but when people start talking about the tools rather than applications or answers they need, you know that they're lost. So talk to me about all of our training courses, please. Also talk to me about the exciting consulting work that we're doing through Advantage Data. Unfortunately, Theo, one of the partners of Advantage Data, couldn't make it tonight because guess what? He's working on an engagement. See, some of us are busy, but I'm here. So ask me about Advantage Data. We are doing some cool stuff. Also, if you're looking for work as a data scientist or a data engineer or more generally some sort of analytics professional, and you're looking for that work either in Australia or overseas, come and talk to me about AlphaZetta, an organization I'm very proud to be chief data scientist of. It's currently in about 30 countries with about 400 consultants. And the only reason it's only 400 is because we're very, very picky. But I'm sure you're all high caliber people, so you probably have no problem getting into AlphaZetta if you want to live the dream of a freelance data scientist. Finally, as mentioned in the introduction, I run 1 or 2 meetups, most notably Data Science Sydney, which I'm proud to say has about 4,700 members now, as well as the R user group, which is older but slouching along at only 2,500, plus a bunch of others. And data visualization is now a regular group with about 1,000 members. And the exciting and emerging one, which is still quite small, is the quantum computing group. Plus there are groups I run in other cities like Canberra and Brisbane and Perth. So lots to talk about when it's drinks time. Now, let's go to a thought experiment. And this thought experiment is, for me, emblematic of much of what I see in data analytics generally and data science especially. Let's say the boss has given you a job, and the job is you have to build an airport. And I hope everyone knows and loves Gavin Belson as much as I do. Now, we're in a parallel universe here. So this is a parallel universe, much like our own, with one very small difference. In this parallel universe, everybody involved in this particular project, which means they have the funding, the mandate, and the apparent need to build an airport, they all think that this is an airplane. Now, I'm a data scientist, so I'd want to take a quantitative survey if I could, but my hypothesis is that if I took a survey, some proportion of you, probably an overwhelming majority, would tell me that that is not an airplane. They might perhaps suggest that it's some sort of elephant, maybe. So what I want to talk about is something called a fundamental category error. I want to talk about this problem that arises where you get something at the very beginning so fundamentally wrong that it throws everything else off. And I have to say, what I'm talking about is symbolic. I don't actually think there are a lot of people out there who think airplanes are elephants, but I actually think that that level of error pervades our industry. And so imagine that everyone thinks the elephant is an airplane. That is a fundamental category error. Now, anything done with this misconception in place will be a waste of time, money, and resources. Agreed? I've been building an airport trying to cater to the elephants in terms of building big stables for them and making sure that the airplanes have enough hay to eat and the airplanes don't trample people, and a few questions about why isn't anybody flying yet. You know, this is to be expected if we carry through with a project with this category error in place. And it'll be an enormous waste of time, money, and resources. Now, I'll tell you what I hear people say to me when similar category errors happen in data science. They say, well, you know, yes, it's a problem, but we have to be realistic. Problems happen. We have to accommodate the client's expectations. We have to work around it. So everyone... And what you'll find is that in this universe, you'll be going to incessant meetings where everyone will be discussing the aerodynamics of elephants. They'll talk about the latest in airplane stables and the sort of hay that airplanes need to eat. And anybody who talks about this stuff is considered business focused. And anybody who says, but this is nuts, this is a total waste, will be considered negative and not a team player. they'll be seen, so what are possible criticisms? One is just being negative, one is not a team player, one is just being too academic, right? You're being a purist, you're being an academic. We need to be, you know, we need to deal with the world as it is, this is best practice, just get on with it. I still think this all leads to disaster. I would say that if you're going to be doing something big and something serious, then getting the fundamental issues sorted out would be the first order of business. And this applies whether you're building an airport and you really need the planes to be planes and not elephants, or whether you're doing data science and you really need your machine learning to have predictors and targets. I don't know about you, but I've come across machine learning projects where it's like, what do you mean targets? That sounds terribly technical, and you're a data scientist, go and invent some targets for me. But that is an example, those are two examples of fundamental category errors. Because this is not right. This causes major problems, you know. While your planes are elephants, you ain't gonna fly. Your airport ain't gonna matter. Now, I actually think there are several fundamental category errors affecting the field of data analytics, and particularly data science. I'm going to focus on one. I'm going to focus on one category error that I see causing a lot of grief, and it's one that is a relatively easy one to fix with tremendous value delivered as a result. And this addresses a navel-gazing kind of question of what is a data scientist, with our nice unicorn picture. Thanks again, Sarah. Oh, big hand for Sarah for producing these slides. They're awesome. And let's have a look at a typical job description, and you'll see, you know, there'll be all sorts of businessy words and requirements for standard things like statistics and machine learning, vague things that indicate that the people writing it don't really know their stuff, perhaps like the phrase big data. Communication skills, which is often a red flag, which says we don't know how to communicate with our data scientists, but we're going to make it their problem. And of course, buzzwords like IoT and blockchain. Big data science, that's a really big, well, it's what's called a shibboleth, in my opinion, and you can look up what a shibboleth is. Hadoop, not mentioned as much as it used to be, and sometimes you want someone who's a 3 times Olympic gold medalist and published Nobel laureate. They ask for that as well, with good communication skills. So, you know, stuff. But the thing that I don't see enough of in these job specs is whether they really want a data scientist or they want a data engineer. And the crucial, important, critical point that they're different things. Not only are they different, it's enough to say they're different, and again, you say that they're different to someone who prides themselves on not being technical, which means I'm too important to think logically, and I earn twice as much as you, and you go work out the details. And anything I don't understand is by definition a detail. Whenever people say technical, my first reaction is that's a pejorative term. The thing is that in the minds of those people, you know, science and engineering, well, they both sound technical. They're roughly the same thing, aren't they? They're not aware that these things are actually opposites. They're not just different, they're opposites. In what way are they opposites? I don't mean opposites like tension and conflict, although there can be a bit of that. I mean complementary opposites. You need both, like a left shoe and a right shoe. Now here is a graph of what I mean about the difference. That graph comes from a blog post on the Farnham Street blog, as you can see, and something that Sarah and I had a bit of trouble working out was whether that graph was itself lifted from a book by Eric Drexler, and I'll leave it for you to investigate and maybe read the book. All I can say is it's one of the most powerful blog posts I've ever read. And this graph is one of the most useful and eye-opening graphs I've ever come across. So I'm sharing it with you, and I didn't come up with it myself. So what's going on here? As you can see, there are two flows, and they're heading in opposite directions. One pertains to engineering, and one pertains to science. One is scientific inquiry, and one is engineering design, and I would also say engineering practice. And the arrow, you could say, is flow of information. And the point is that the left of the screen is science, the right of the screen is engineering, but the bottom of the screen is the physical world, it's the real world. And the top of the screen is the world of ideas. Science and engineering work in different ways. Engineering, we all know how engineering works. You do it every day. You've probably not thought about this, and when I explain it to you, you say, yeah, but that's obvious. Engineering starts with an idea in the world of ideas. Hey, I'm going to build a gigantic nuclear-powered rubber duck. Yeah, that's an idea. It's in your head. It's not in the real world yet. And what do? You go and you design it, specify it, create it. There's a process by which you bring it into the world. You impose on reality a new thing that started with your idea. Start with an idea, end with a real world thing. Science, and that physical system, what are you really doing as an engineer? What is engineering? It's building or maintaining something to predefined parameters. Watch this space with the predefined parameters, because while this is a great graph, there are a number of subtleties here, especially subtleties pertaining to data that we need to pull out. One subtlety is that uncertainty is the enemy here. If you're an engineer, you do not want things that surprise you in terms of how they don't meet spec. You do not want surprises in terms of cost overruns or time overruns. And while nice surprises can happen, they're extremely rare. Most surprises are bad. Most bugs make your code not work rather than make it cure cancer by accident. So uncertainty is the enemy. If you're an engineer, you're imposing order on the universe, you're fighting against chaos, and you're bringing into creation something nicely specified. Whenever you have to deal with uncertainty, you do it reluctantly, you do it decisively, and debugging is not the most fun part of your job. So I'm using a workhorse as a symbol for engineers. And I do this as someone with a background in computer science, so don't get mad at me. I would also say that engineers, when we're doing engineering in the context of data science, which I actually don't think is data science, but engineering in proximity to data science, data is a commodity. Data is an interchangeable substance that gets pumped through miraculous machines. The miracle is the machine, and the data is ultimately interchangeable. The miracle is the 3 V's, volume, velocity, and whatever, the things that we can do with data. The focus is on the system. The focus is on the physical thing being created, and one side effect is that uncertainty is the enemy, as it should be when you're building stuff, and the other is that data tends to be a commodity and not the focus. So that's the engineering side of things. What about science? Well, science goes the other way. Science is when we want to inquire about the world. And by the way, I'm not talking about science as in pure science in a lab, though this is true as well. I'm talking about science in inverted commas, which more generally means finding out new stuff, which businesses sometimes really need to do. So inquiry, more generally. Finding out new things about the world. You start with the world as it is, and you end up with a new idea, a new insight, a new thought. Here, data is something we explore and interrogate for insights. It's not a commodity. The data can contain many different things and say many different things, and it is the focus of the analysis. The machines we use for the data are secondary. So when people tell me that I'm the R guy, I shrug my shoulders and say, yeah, that's because R is great for the job and Hexo is Python. But I'm not focused on either of those. I'm focused on the task and I'm focused on the data. And uncertainty is the job. Uncertainty is the reason you have a job. You get up every morning and say, the world is uncertain and it's my job to figure out what the heck is going on in it. I don't know what I'm going to find. So this is another point. The engineer is imposing something on the world with certainty. So if I succeed, I'm going to build this thing to these parameters, to this spec, possibly according to this plan. You can go agile, you can go waterfall, doesn't matter. But you're building something reasonably to spec. The scientist goes, I know what I'm going to investigate. I know what question I'm going to ask, but I sure as heck don't know what I'm going to find. And if you're putting that in the context of a business process and you're saying, all right, depending on what we find, we've got to do A, B, C, or D, I don't even know what my next step is going to be. Now, I have had to explain this very point to a very high-level client last week, where they asked me for a project plan, and I said, I don't know. I can guarantee you one thing, whatever workflow I come up with won't be the workflow we end up with. I can guarantee you that, because I can only see one step ahead. The products of my little Gantt chart entities are findings. They're not my deliverables are findings. I don't know what the findings are going to be, and I don't know what the consequent actions will be based on those findings. Welcome to R&D. So scientists develop an understanding of the world, starting with the world as it is. Data is much more their focus than the machines that push the data around, though we need those. Like, scientists need microscopes, but the focus isn't the microscope, it's the bacteria or whatever the heck you're looking at under the microscope. And uncertainty is fascinating. We love uncertainty. Uncertainty is the reason we have a job. Our relationship with uncertainty in data is very different to that of engineers. When I say ours, it's also true, as I'll say later, that we are, of course, a bit of both. So scientists are focused on the data, and their objective is to tell the story of the data to someone who cares or matters, ideally the CEO. So now I'm contextualizing this in a business context, and I'm saying that a scientist's job is to find something new and communicate it to someone who's going to make some use of it. And here we have a contrast between scientists and engineers. I guess engineers are winning in this particular competition by virtue of actually being real. I'm not sure I want to be a unicorn. Other than that, well, I guess being multicolored is pretty cool, isn't it? So there is an interchange. There is a dynamic interchange between the two. There's a virtuous cycle between the two when you think about it, because as science develops new ideas, those ideas feed into new possibilities for engineering. Yeah? And as engineers develop new things, those new things assist sciences with doing new kinds of investigation. We need each other. And as my point earlier was made, it's not that you're one or the other. You're usually kind of both, but you tend to be primarily one. And it's good to know which one it is. Why is there this confusion? Why can't people understand this very, very fundamental difference? And by the way, I see the lack of understanding impact organizations in many different ways. And if we have time for questions, I might get into all of that. Well, there's that whole it's all technical thing. So people who didn't get through algebra in year 9 and spent the rest of that time learning to manipulate human beings while we were trying to learn to excel cognitively, those people have this category technical, which includes all the unknown unknowns that actually should matter to them, but don't. So it's all technical, engineers, technical, science, technical. It's got the word data in it, so it must be technical. I used to say to my business partner that data is a hypnotic word. It's a word that tells the important non-technical people that they can switch off now. So if I say, well, the data informs us that there is a positive relationship between the following predictors and the target, what they hear is, well, the data is blah, 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 blah. Because at the moment they hear the word data, they go, this person is not important enough to listen to. And I think that some groups actually benefit from the confusion. I think there are tribes of management and a whole ecosystem of vendors that love this confusion, and indeed, I believe that there are industries, certainly companies, that would go out of business tomorrow if this confusion was disambiguated. I also think that a lot of people responsible for the hiring process, and that includes everybody from the management specifying the job to the internal HR to the recruiters, are quite out of their depth in terms of understanding the real needs of the hiring party. And when the hiring party doesn't think it's their problem to understand those needs, which is interesting in itself, we can have this level of plain elephant confusion. Now, a real business needs both. I will say this, businesses tend to need engineers more routinely than they need scientists. Businesses also know what to do with engineers. So generally speaking, the way businesses resolve this is They think all technical stuff is engineering because that's all they've known and that's all they've managed, while the science stuff is an unknown unknown for a number of reasons. Now, you need engineering in just about any business at all, but science is crucial if you're dealing with real competition and real risk. Otherwise, not so much. And the way they divide is that engineering provides delivery, engineering makes real things happen, and we need that. Science provides intelligence. Science is the equivalent of an ostrich pulling its head out of the sand. What's the ROI of an ostrich pulling its head out of sand? Well, if I have to explain it to you, maybe you should be someone else's client. So a related question is, where do we put the data scientists? Do we put them under, wow, it's an organization of Gavin Belson clones. This is a nightmare, Sarah. So do we put them under, I don't know, Gavin Belson drone clone middle manager here? Do we promote our unicorn to be a peer of all the Kevin Belson middle management drone clones? Or do we have our unicorn reporting directly to Kevin Belson Prime? And now it sounds like the Borg, doesn't it? Well, let's think about what the profile of our little unicorn is personality-wise. And it's a mix of Scully from the X-Files in terms of you need someone who's rational and someone who's not just by nature rational but also trained in logic and mathematics and statistics and causal inference and computer science. You need them to also be innovative. You need them to take these skills and do new stuff with it in an inquisitive, helpful, and useful way. And you need a Steve Jobs vision and business acumen. You need to be able to cut Gordian knots. You need to be able to impress the right people at the right time. You need to have on the one hand the soft skills, and on the other hand that vision for what matters and where it fits. But what's important to note is that one thing about Jobs is he ain't IT. And one thing about Shuri is she ain't no waterfall project management drone. So you need someone who's definitely not in the IT function. I really don't think data science fits in the IT function. And I really don't think data science can or should be managed in anything resembling the project management processes today. And this includes a lot of what passes for agile, by the way. We can debate as to whether it's real agile or how much actual agile is out there. But all I'll say is this. If you're managing towards a known outcome, it's not data science, even if you're flexible in the method, because data science can only promise to look. It can't promise what it's going to find. And it's not business as usual. If you're doing the same thing every day, maybe with a slightly different data set, that ain't data science either. By this definition, by the way, a lot of the rather cool predictive modeling, machine learning that's being done is probably engineering. And that's cool. That's fine. I just don't think it's only science in as far as it's conducting inquiry to find out something new. So a bit more navel gazing, what is data science and analytics and where might it fit? So I promised to tell you where it fits, and so far I haven't really. I've told you where it doesn't fit, and that's kind of deliberate. I think not putting it in the wrong place is much more important than worrying about where the right place is, especially because most organizations don't have a right place. What's the right place? Something like the intelligence function in the military. A function whose job is not to do business as usual and whose job is not to do defined projects, but just whose number one and only job is to keep eyes open and spot opportunities and threats. That's what intelligence does in the military. Does your business have a function like that? A lot of businesses do informally. A lot of large businesses don't at all, or not seriously enough. So a bit more navel gazing on what is data science and analytics. Some key questions to tell you whether it's being done well and whether it is in fact science at all. So is it about generating insights, or is it primarily about a process? Is the focus on outcomes, decisions, decision support, or important metrics like predictive accuracy, or is it about tools? Are we always talking about stack, or are we always talking about what we're doing with it? Is it about transformation? Is it about doing something new or reacting to new external forces, or is it all business as usual? Is it done for value, or is it being done for compliance? Is it done to actually, again, deliver value as an asset, or is it being done worse for vanity? More on that later. Is management engaged, and is success being measured? So, on the one sense, whether it's insight or a process, insights are different every time. Now, data science can generate processes. It generates processes all the time, but it is not itself a process. And deriving value from insights from a model, well, that's not a repeatable process. The actual predictive side of it is, but not the insight side. And the insights are highly valued only by those businesses that are under pressure from risk, under pressure from competition. Thank you. Doesn't look like I'm going to get through this, but we'll make the notes available. Data science can help set up businesses as usual processes, and analytics can derive value from predictive targeting, of course, and that requires an engineering function. There are a number of conceptual skills required to achieve data science outcomes. I've been told I've got 10 minutes, so I'm going to hurry along. It's not about the tools. However, the tools are very important for creating the technologies that data science leaves in its wake. But the focus of data science itself is not tools. Indeed, what you want are tool-agnostic, incredibly rational, but also incredibly flexible minds, human beings. A few other thoughts, which is that a lot of data science functions out there are what I call vanity projects. So a data science as an asset project is one where you have clear goals, clear reporting lines, clear purpose, a very engaged management, and it fits a business need. A vanity project goes like this. I'm an important person and I have a huge budget. I want to be associated with data science. I'm launching a data science project. First order of business, let's have a meeting about what we're actually going to do. We don't have an actual objective. We don't have an actual target. We don't know what we're doing, but we have to look. The idea is the KPI is to look like we're doing some data science. That's called a vanity project, and I don't like those. You may have seen one. The other issue is engagement. Is management engaged, as in curious, demanding, interested in insights? And if they're not up to scratch in interpreting those insights, putting pressure on themselves to become educated and bridging the communication gap with the data scientists by meeting them halfway instead of saying, because I don't understand everything you're saying, it must be your fault. Not that this thing is so complicated that I can't get the key concepts through my head. I've seen businesses with engaged management, and I've seen the opposite as well. And finally, is success being measured? Again, you'd think this is a trivial question, particularly when we're talking about predictive modeling, but I'm surprised by how little measurement there is and how much less of that measurement is actually effective or correct. So just because you're measuring something doesn't mean you're measuring the right thing. So one question is, do you need a data science function? How much more do I have? Right. And the answer is, you only need data science if your business is facing real competition, real threats, real uncertainty, and real change, which impacts directly and personally important people in the business. If those things don't hold, you don't need data science. And before you go, well, this is trivial, isn't it? No. There are precious few businesses that I come across where this is actually true. And their interest in data science is for reasons other than they are facing these pressures that require real intelligence. So I actually don't think most businesses need it. If, however, they're looking for unicorns, the skills are rare, and most of the hiring is severely out of depth. We'd need you to dynamically orchestrate extensible value. I think Sarah found a business gobbledygook generator to come up with that one. Science me 1,000 models by Friday. You'll have managers sort of firing off demands on things they don't fully understand. Well, what does good look like? I actually have a case study here of what a good, of a job description for a good job. And I'll zip through it quickly and just tell you that there are a few important characteristics. It's concise. All the HR boilerplate and why our company's best propaganda is at the bottom, so you don't have to read it. There are clear outcomes. There's a reasonable list of tools and skills, and there's a clear separation of requirements from the wish list stuff like must have presented at top-tier conferences. I have a case study here just to show you that it's not all doom and gloom, and some organizations do get it. And when you have a CEO who's engaged and knowledgeable and has skin in the game, as happened in this case, which is a small financial services company, miracles happen. And you get a very flexible, very cheap and very quick result, which develops a virtuous cycle with ongoing improvement of the, in this case, credit default model that was built. The key was that you had a CEO with skin in the game. This CEO was analytics aware. He'd actually done a couple of my training courses, including my advanced masterclass. And the CEO actually wanted this business to succeed. He wasn't doing this to look clever. He was invested in the business. And they knew, for example, that they didn't need to go and hire a brand X data scientist. They needed some good advice first. And that's probably some good advice for you. Some good advice up front, some good consulting, and experimentation, especially when you don't know what you need, is worth a lot of pain later. So here is Sarah's Star Wars analogy. A long time ago in a business environment far, far away from competition, which is where they all start, data science. So it's a period of intense competition. Rebel disruptors striking from a hidden base have won their first victory against the dominant business players in various markets. So data science done well, you have management who know what they want. Data science is there to support their decisions. And they have clearly defined outcomes, and they're measuring those outcomes by metrics. And data exists, and the manager will step on anyone who doesn't give the data scientist the data. So there aren't these turf wars for, IT has the data and won't give it to data science. And then it can all happen. And the manager knows that he needs both engineering and the data science unicorns, and they're not the same thing. And then you have this virtuous cycle, this flow, which also includes, well, doing stuff, measuring it. Is the measurement good? Great. Let's make some decisions. Yay, vision realized. And I should also point out that on next week, I think, is that next week? On May 29th, I'm doing a talk for Data Science Sydney on KPIs for strategic decision making, which is not something that people generally measure. You'd think that the most important decisions in the business would be the most important ones to measure and assess, but no. And that takes us to maybe, 1 minute of questions.